Good day, ladies and gentlemen. This is Sarah van Greden, aka Mr. VG, and we are now slowly but surely getting to the end of sequences and series for the November 2021 DBE exam. In this series, we're working through the question papers little bit by little bit, looking at the different sections, how to analyze it, what things you need to look out for. So please watch every video. Make sure you understand this. And I know you are going to ace your exam. I know it. Not because I'm awesome, but because you are working hard and you're putting in those extra miles while your friends are out partying. So well done, grade 12. Well done, grade 12 students, for giving your time up for your own future. Now, this video specifically, we're going to look at arithmetic sequences and series, because this question is question 4. It says consider the linear pattern 5, 7, and 9. And I just copied and pasted the little bit of the formulas sheet there at the bottom. I want you to try the sum yourself before you do anything else. Hit the pause button, try it, and then come back and watch the rest of this video. So when we start analyzing a question like question 4, the important thing is to analyze the information. Consider the linear pattern, in other words, the arithmetic sequence. So there must be a constant first difference, which makes it arithmetic. So when I look at question 4.1, well, before we get to actually answering it, let's look at which formulas I'm going to use. Those two. So when we look at question 4.1, question 4.1 is very, very simple and straightforward. I'm simply going to write out the formula. I'm going to substitute my A and my D values in there. Now, which term am I looking for? I'm looking for term 51. So I'm going to substitute n with 51. Now, this is important. This means the 51st term is going to be 105. I want you to put a pin in this one because in 4.2 we're actually going to use it. But in 4.2, now they're asking you the sum of the first 51 terms. So when we look at this, I'm going to the SN formula. I'm going to substitute my A value in. I'm going to substitute my D value in. And which one am I actually looking for? I'm looking for the sum of the first 51 terms. I'm replacing every n with 51. If I put it in my calculator, I get a value. But here is something I want to show you. Those of you that are getting 80s and 90s, I want you to think of every question as having 2 or 3 alternatives. What is the second alternative? Why don't I use the other SN formula? A plus the last term. Don't you have the last term? Well, yes, sir. Actually, I've got the 51st term. That's 105. Remember, that is L. That term 51, that is actually your L. Oh, that L is a bit long. There we go. So I'm just going to substitute that in. And I get my S51, and the answer is 2,805. Well, which one is better to use? Your choice. But 80s and 90% are specifically always look for 2 alternatives to every single sum. Let's look at the next question, question 4.3. This is now where it becomes not so lacquer for my students. I don't really understand why. See, sigma, oh, my students hate it. But sigma just means sum of. So when I look at sigma, I replace n with 1 first of all, adding, then replacing n with 2, and replacing n with 3. All the way up to replacing n with 5,000. Why do I stop at 5,000? Because again, that's my last term. Now I love to do this. Write out the first 3 terms. Sorry for that. Write out the first 3 terms and the last term if necessary. How do I know if it's necessary? You don't really, unless you want to use the A plus L formula. But let's write out the first 3 terms. 5, 7, and 9. All the way up to 10,003. Interesting, don't you see that that's exactly the same pattern that was given right at the beginning? So actually, this is just a normal SN formula. Okay? But the question is not actually, let me just quickly go back. The question is not actually calculated. The question is just show the first 3 terms and the last terms. I can go and calculate it, but then I'm wasting time. Remember, this is worth 1 mark. Look at that. 1 mark. Okay? Now we get to the actual question. Hence or otherwise, calculate sigma from n equal 1 up to 5,000 of 2n plus 3. That's exactly the one we had in 4.3. Exactly the one we had in 4.3. Plus sigma from n equal 1. Now this only goes up to 4,999. Something to look out for. Of negative 2n minus 1. So what I'm going to do is I'm going to break it up. And I'm going to just calculate those first things that I want to do. Okay? Let me just go over that. I made a small silly mistake there at the beginning. So let's start by first, again, writing out the first sigma. But that's exactly the one we had earlier. But now they're asking me, add to that the second one. So I'm just going to handle it exactly separate from one another. Ladies and gentlemen, I'm going to handle it separate from one another. So basically, the top row is exactly 4.3. Then I'm going to go to the bottom one and I'm going to have the second sigma. I'm just going to write out the first 3 terms for now. So this means I've got 2 plus 3 plus 4 plus 3 plus 6 plus 3. So where does, before you freak out, that's the first term of the top one, the second, the third, okay? It looked weird the way I wrote it. That's why I love to put things in brackets, okay? And now you might say, but so why don't you just use what is written in 4.3? You'll see in a very short while why I'm not going to do that. Now I'm going to add to that. I'm doing exactly what I did with the second term, okay? All the way up to substituting the last one in. Let's just put brackets around the first, the second, the third one, and then the last one. Now, I made, again, just one silly mistake here. That's not 998, that's 9998. Remember, that is the 4,099. 999. So many nines, I'm getting confused. Why do I write it above one another? So that hopefully you start seeing a pattern. What is the pattern? Let me go back a little bit. Negative 2 and the 2. cancel out. I hate that word cancel out, but let's use it. 2 minus 2 is naught. 4 minus 4 is naught. 6 minus 6 is naught. That's going to carry on and on and on. And all my first terms are every time going to cancel out, all the way up to that last one. Even the 9,998 is going to cancel out. Let me just do that with a 9,998 there. Then what is going to be left over? I'm going to have a 3 minus 1 for my first term. Oh, look at the second brackets. 3 minus 1, so there's a 2 as well. What about the third brackets? Oh, so there's again going to be a 3 minus 1. Oh my goodness, there is like 4,998 2's there. Oh my goodness. But which one is not going to cancel out? Well, that 10,003, that one right at the back there, that one is not going to have anything that cancels out. So I've just got to add it. So this means I've got 2 times 4,999 plus 10,003, which means the final answer is 20,001. Oh my goodness, this was gorgeous. This was beautiful, beautiful, beautiful. Let's just backtrack a little bit. Let me just talk through again my thinking. The first sigma is just 4.3. The second sigma I write on top of one and I write below the first one. Then, because I'm working with such big numbers, I would start thinking, you know what, maybe, just maybe, things are going to cancel out. And they do cancel out, okay? They do cancel out. That's the beautiful thing. And a lot of times with sigma, when you're working with these weird sigmas, always write out the first few terms. See if there isn't some kind of pattern, some things that become 0, that become 1, that cancel out, okay? Because the examiners love to ask it. They love to ask it. Could I have gone straight off and substituted into a formula? Most definitely. Most definitely. If you did this, and I'm going to just erase my working out here. If I just went into a formula, I would get exactly the same answer. So let's quickly see. Okay, let's quickly see. If I go to the formula for the first one, S of 5,000, okay? I'm going to use the formula 5,000 over 2, A, which is 5, and the last term, which is 10,003. If I look at the second one, remember now I need to add to that S of 4999. And this is 4999 over 2. The first term, if I wrote the first 3 out, is going to be, let's just quickly do it here on the side, negative 2 times by 1 minus 2, minus 1 is negative 3, so that is my first term. And if I add the last term, so negative 2 times by 4999 minus 1, and that is going to be a beautiful negative 9999. That's a lot of 9s. So I'm going to substitute that into there, and I get exactly the same answer if I add them together. 20,001. Oh my goodness, this is beautiful. There's so many different ways you could do it. You could do it the elegant way by cancelling things out. Or you can just do it like a bull in a china shop and just substitute into your formulas. You get the same answers. Oh, wow, maths is beautiful. Ladies and gents, this concludes our first section, or our second section actually. Wow, already past the second section. Wow, the second section in your paper 1 preparation, sequences and series. So stay tuned, keep well, keep safe, make sure you get your results end of the year. This is Mr. VG signing out. Have a beautiful rest of your day. Keep well. Cheers.